I am Shreyash and this is Provenant. I started with a simple observation. Over the last 2 years, AI coding agents have become dramatically better at reasoning, planning, and generating code. But despite all that progress, they still spend a huge amount of time doing something surprisingly inefficient reading, and usually reading far more code than they actually need. That's the idea behind Provenant. And as you can see on the slide, Provenant helps AI coding agents read dramatically less code while preserving repository understanding. So the goal is not to make the model smarter, the goal is to make every token the model reads more useful. The team consists of me and Kritika. And this project was built under the AI powered production function theme. Slide 3, the problem. This slide summarizes the 4 problems that motivated the project. Starting on the left, there is a vocabulary gap. Developers ask questions in natural language, but repositories store implementation details as source code. That mismatch makes retrieval difficult. The second card shows the consequence. On SW Bench Verified, more than 40% of the task missed the correct file in the top 5 results. When retrieval quality drops, agent compensate the only way they can. They read more context. The third card highlights another issue. Most retrieval systems have no quality signal. A bad retrieval looks identical to a good retrieval. The system never learns whether the retrieved context was actually useful. And finally, on the bottom, we see the cost problem. Agents repeatedly consume large source files even when a compact architectural explanation would have answered the question. The result is more tokens, more cost, and not necessarily better understanding. The solution? So, that's the core idea behind Provenant. Instead of retrieving raw source files, Provenant builds an attributed wiki index for the repository. You can think of it as converting implementation details into a repository knowledge. The impact is summarized by these 4 metrics. Retrieval quality improves significantly. We see meaningful improvement over raw retrieval. Context consumption drops by 64 times. And because Provenant tracks attribution confidence, it can identify weak pages and repair them automatically. The 3 sections at the bottom show how that happens. Token efficiency demonstrates the compression achieved. Attribution confidence provides a measurable quality signal. And the repair loop allows the repository memory to improve over time rather than remaining static. The most surprising outcome of the project was not retrieval quality, it was economics. On the left side of the slide, we see a typical retrieval workflow without Provenant. The agent consumes almost 70,000 more tokens of raw source context. On the right side, Provenant reduces that to roughly 1,000 wiki tokens. That's 64.5 times reduction. The bottom section translates that into business impact. If you scale retrieval heavy coding workflows across engineering teams, reducing unnecessary context consumption creates a substantial reduction in AI infrastructure cost. The idea is simple. Spend tokens on reasoning, not on reading. So an idea like this needs validation, and the validation needs to survive measurement. This slide summarizes the benchmark results. I evaluated Provident on 500 SWE bench verified tasks across 12 Python repositories. The table compares 3 retrieval approaches: raw source retrieval, wiki-based retrieval, and full Provident pipeline with re-ranking and selective height. Across every metric, retrieval quality improves. But the 3 cards underneath are equally important. The first explains why wiki pages help developer ask in natural language. The wiki bridges that gap. Then we have async repair. As you keep on using Provenant, it repairs itself and the low index pages. And the third shows deployment simplicity. 3 commands, that's it. Install, index, serve. No cloud account, no repository restructuring, and no heavy infrastructure requirements. And we have methodology. This diagram shows the complete Provenant lifecycle. Starting on the left are repositories indexed and converted into wiki pages. Those wiki pages are then stored inside both lexical and semantic retrieval systems. At query times, Provenant retrieves relevant pages and generates an answer and tracks which page actually cited. The confidence score show in the center becomes the key quality signal. If confidence falls below a threshold, the system schedules a repair task automatically. The repaired page is then re-indexed and becomes available for future queries. At the bottom, the three evaluation axis summarizes what was measured. It was measured on 500 tasks across 12 repos. Stock efficiency we've all talked about 60 to 65%. And then we have confidence graded repair. The working prototype, there is another video attached of the demo. And attachments, well, you can see all the attachments. Click on the links. It's publicly accessible on Python. It's open source. You can see the GitHub repo, and the white page is also attached here. So the closing is the AI industry spends enormous effort making models smarter. Provenant focuses on a different bottleneck, helping those models understand repositories more efficiently. Because the future of AI assistant development isn't better models, it's better memory and cheaper workflows. Thank you.